Welcome back, everyone. Myself, Tanya, is from the Department of Computer Science and Engineering, Artificial Intelligence. I am from Sri Venkateshwara College of Engineering, Bengaluru. So today's subject is about mathematics. The topic is basic concepts of probability theory. Firstly, introduction to probability theory. Probability theory is a branch of mathematics that deals with study of uncertainty and randomness. So it provides a framework for quantifying and analyzing the likelihood of events occurring. Probability theory is widely used in various fields, including statistics, economics, and engineering field. So this probability is mainly dealing with study of uncertainty and the randomness of an event. So this quantifies and analyzes the likelihood of event which is occurring, and it is widely used in the various fields like statistics, economics, and engineering. The central objects of probability theory are random variables, stochastic process called random process, and events. The probability theory is a mathematical foundation for statistics. As a mathematical foundation for statistics probability theory is essential to many human activities that involve quantitative analysis of large sets of data. Method of probability theory also applied to descriptions of complex systems given only. Next is sample space. The sample space is a set of all possible outcomes of an experiment or random event. It is denoted by the symbol capital S and represents the total set of all possible outcomes. Each outcome in the sample space is called an element or sample point. It is called as element or a sample point. It has to be noted importantly. So the sample space is a set of all possible outcomes of an event or a random event or an experiment. So it represents the total set of all possible outcomes. The probability experiment, a chance process that leads to well-defined results called outcomes. Example, flipping a coin, drawing a card. So flipping a coin, as we take an example, so we don't know the what will be outcome, right? So if we toss a coin or flip a coin, the outcome will be tail or head. So we keep in mind as in 50-50 of each event. So that will be the example of a probability experiment. What is outcome? The result of a single trial of a probability experiment. Sample space, the set of all possible outcomes of a probability experiment, as I said before. Next is events. An event is a subset of the sample space that consists of one or more outcomes. Event can be simple, consisting of a single outcome, or compound, consisting of multiple outcomes. The occurrence of an event is determined by the outcome that belong to it. So definition, a subset E of outcomes is called an event E. Probability of an event, the basic formula is P of E is equals to total number of outcomes in an event divided by total number of outcomes in a sample space. So we can shortly call it as N of E by N of S. So event is a sample space that consists of one or more outcomes. So it consists one or the multiple outcomes. So it can be simple or complicated. The outcomes will be multiple or the single two. So occurrence of an event is determined by the outcomes that belong to it. So outcome will be dependent on the occurrence of event. The next is probability of an event. Probability of an event is numerical measure that represents the likelihood of its occurrence. It is denoted by the symbol called P and takes values between 0 and 1 inclusively. 0 and 1 inclusively. The probability of an event can be interpreted as the relative frequency of its occurrence in long run. So the probability of an event is a numerical measure that represents the likelihood of its occurrence. So it mainly represents the likelihood of its occurrence and it is denoted by P. It takes the values between only 0 and 1. So the example is, what is the probability of spinning blue? So as I said the formula before, N of E by N of S, the total number of outcomes is here 8, but they have asked only spinning blue. So the blue will be 3 by 8. The answer will be 3 by 8. So the next is theoretical probability. Theoretical probability is based on the assumption of equally likely outcomes. So it is calculated by dividing the number of favorable outcomes by total number of possible outcomes. Theoretical probability is often used when all outcomes are equally or likely, such as rolling a fair die. So it is the assumption of equally likely outcomes. So it is calculated by dividing the number of favorable outcomes by the total number of possible outcomes. So here is the formula of it. Frequency of event occurring by total frequency of possible outcomes. So mutually exclusive events can be happen in the same time. For example, a fair die cannot land a 3 and a 4 at the same time. And a coin flip cannot land on heads and tails at the same time, right? So if an object called a coin, spinner or a dice, for example, is described as fair or conversely non-based, the theoretical probability of each outcome is the same. The theoretical probability of flipping a coin is 1 by 2, right? The two outcomes will be coming whether it is tail or head. If it comes head, it will be 1 by 2 only, and if it comes tail, it is 1 by 2. So the theoretical probability of rolling a 2 on a fair 6-side dice is 1 by 6. So in each 6 sides, there will be 6 numbers, 1, 2, 3, 4, 5, 6. So in that 6 numbers, 2 will be occurred only once, and it is present in only one thing. The next thing is experimental probability. Experimental probability is based on actual observations or data from experiments or trials. So it is calculated by dividing the number of times an event occurs by the total number of trials. It is divided by the number of times an event occurs by the total number of trials. Experimental probability is useful when the theoretical probability is difficult to determine or not applicable. So it is mainly useful when the theoretical probability is difficult to determine or not applicable. So it is calculated by frequency of event occurring divided by total number of trials of an experiment. So experimental probability will be happening based on the actual experiment or an observation. So we can also express this as R is equal to F by N, where R is the relative frequency and F is the frequency of event occurring and N is the number of trials of the experiment. If we find the relative frequency of all possible outcomes from the experiment, we can write the probability distribution for the experiment. So the main thing, we have to find the frequency of an all possible outcomes over here. The next is complementary events. The complementary events of an event A is the event that A doesn't occur. It is denoted by A dash or A bar and consists of all outcomes in a sample space that are not in A. The sum of probabilities of an event and its complementary event is always equal to 1. So the sum of probability of an event and its complementary event is always equal to 1. And the complementary event of an event A is the event that A doesn't occur. So in A itself doesn't occur in this complementary event. So it is known as complementary event. A complement of A denoted by A dash or A bar consists of all outcomes in which the event A doesn't occur. So P of A plus P of A dash is equal to 1, or P of A is equals to 1 minus P of A dash. Depending on the problem, it may be easier to find P of A dash than use the above equation to find P of A. So these both equations will be easy to find out how the question will be prepared or how the question will be asked. Next is independent events. Two events A and B are independent if the occurrence of one doesn't affect the probability of the other. So mainly here, if the occurrence of one does not affect the probability of other. If A does not affect the probability of B, the two events will be independent. The probability of intersection of two independent events is equal to the product of their individual probabilities. So independence of an event is a fundamental concept in probability theory. Here the example is, if A and B are two independent events, prove that A dash and B are also independent. Two events A and B are independent if P of A bar B is equals to P of A into P of B. So now P of A and B is equal to P of not A and B. So this is equal to P of B minus P of A and bar B. So P of B minus P of A into P of B. The formula we are using here, P of B into 1 minus P of A minus P of A. So the answer will be P of B into P of A. Since P of A and bar B is equal to P A dash into P of B, hence A dash and B are independent. So the next is variance and standard deviation. Variance and standard deviation are measures of dispersion or spread of random variable. Variance is calculated as the average of square differences between each value and the mean. Standard deviation is the positive square root of the variance and provides a more interpretable measure. So here standard deviation is a positive square root which the variance and it provides more interpretable measures. Variance is calculated as the average of the square differences between each value of the mean. And variance and standard deviations are measure of the dispersion or the spread of a random variable. So the formula is S of x is equals to root of summation of I into I to n is equal to 1 xi minus x bar whole square by n minus 1. So the number of data points, each of the values of the data, the mean of xi is. So here there are some normal distribution graph. So as you can understand here. Last part is conclusion. Probability theory is a fundamental concept in mathematics and has wide-ranging applications. Understanding basic concepts such as sample space, events, and probability calculation is essential. Probability theory provides a powerful framework and analyzing uncertainty and making informed decisions. So this probability theory is a fundamental concept in mathematics and it is a wide-ranging application. So it has wide range of applications and it is a fundamental concept in the mathematics. So understanding the basic concepts such as sample space, events and probability calculation is essential where you can define a problem or make a problem yourself a easy thing. Probability theory provides a powerful framework for analyzing uncertainty and making informed decisions. As I said before, with this probability theory, we can be sure that how to find a uncertain or random value experiments answers. So thank you for joining this wonderful session. Thank you everyone. Thank you for this wonderful opportunity.